Hi class, this is section 6.5 that we are going to talk about today, and we are going to be learning about circumference, and then we are going to do a mini conjecture or a mini investigation from your book. So most of you probably already know the circumference of a circle, but I'd like to just do a little investigation in Sketchpad. So if you will open up Sketchpad and make a circle, and then construct a diameter. So I'm going to highlight the point on the circle first, and then I am going to construct a ray, and then highlight the other intersection point, and then construct a segment so that I have just a diameter, and then I'll hide the ray. Okay, so there is my diameter of my circle. Now if I highlight just my circle and say measure the circumference, it'll give me the numerical value, not in terms of pi. So where does pi come from? If I take the circumference and I divide it by the diameter, so there's my diameter, CB, so I'm going to go into my calculator and take the circumference and divide it by the diameter. I get 3.14, which of course Sketchpad rounds off, is the same thing as pi. So that's where pi comes from. The length all the way around a circle divided by the length of the diameter will always give you pi. So let's put this in our notes and complete the conjecture. So the conjecture says if C is the circumference and D is the diameter, then there is a number pi such that C equals pi times diameter, and I'm just going to write pi because I don't have a symbol for it here. Pi times the diameter that gives me the circumference if diameter is 2 pi. But if it's just given in terms of r, then their circumference is pi, I'm going to put the 2 first, 2 times pi times the radius, where r is the radius. So 2 pi r, and maybe I should go ahead and write out radius there. But 2 times the radius is the same thing as the diameter. Okay, so either formula that you want to use is fine with me. And you also need to remember that circumference is the length around the circle. Okay, we can't measure curved surfaces, so we need to use this formula. Okay, the second conjecture that we're going to do today has to do with two intersecting chords. So here's your mini investigation. Use what you know about inscribed angles and exterior angles of a triangle to help find the missing angle measures in each diagram. Examine these cases to find relationships between the measure of angle AEN and the measures of two intercepted arcs AN, arc AN, and arc LG. So if we're looking at this, we're looking at angle AEN where the X is. Look at its intercepted arc. Look at the other intercepted arc. So we're going to come up with a conjecture in order to solve for X. Now, notice this angle is not a central angle, nor is it an inscribed angle. So the angle that's being made is not anything that we have looked at. Okay, so let's see what we can come up with. Let's go back into Sketchpad and make a circle, and I'm just going to make two intersecting chords. So I'm going to put a couple other points on the circle. And then I'm just going to construct, I think I missed the circle there. I am going to construct a couple of chords. So highlight your segments, or highlight the points and construct segments. So that you have two intersecting chords. Okay, so we know the vertical angles are congruent. You know that adjacent angles are supplementary. But let's look at the measure of the angle that I just constructed here. So I'm going to put the intersection point in the middle, and then I'm going to measure the angle. So I am going to have to highlight the segment. See, I'm going to construct all of these as segments. Okay, so now we know, once we know one of these angles, we should know the other three. I'm going to measure the intercepted arcs. So I'm going to highlight the 2 points and then the circle, and I say measure arc angle. And then I'm going to measure the one that intercepts the vertical angle. Okay, now look what happens. When I go to my calculator and I add the 2 arcs together, and then divide it by 2, I get the same measure as my angle. Okay, so look where these arcs are. There's arc CA, there's arc DE. So these 2 angles here are congruent. Angle ABC, that's 84.97. Okay, I could put this measure in as 84.97 as well. So you can really see this conjecture here. So you take the 2 arcs that are formed by the 2 intersecting chords from the congruent angles. You average them together and you get the measure of the angle that is formed. Now let's make sure the same thing happens if I do it from the other angle. So let me move these back out of the way. And let's look and see if the same thing happens if we measure angle FBC, if it's the average of its 2 intercepted arcs. So I'm going to measure the angle FBC. We know EBA will be the same measure. So now I'm going to measure arc FC. And I'm going to measure arc EA. And I'm going to pull up my calculator, and I'm going to take the 2 arcs and add them together. And then I'm going to divide it by 2. And lo and behold, I get 95.03. So let's complete our mini investigation. The measure of an angle formed by two intersecting chords is half the sum of the measures of the two intercepted arcs. And there is your intersecting chords conjecture. That completes this lesson. I'll see you in class.